Hi everyone, I am Dr. Sadish Kumar, Professor, Department of Physics, K.S.Rangasamy College of Technology, Tiruchengodu. Today we will discuss about the laser. The topics covered: introduction, characteristics of laser, types of pumping, spontaneous emission and stimulated emission, the working of ND-OAG laser and laser application. The laser The laser is a device that emits lights through the process of optical amplification based on the stimulated emission of electromagnetic radiation. The word laser organized as for light amplification by stimulated emission of radiation. The laser characteristics. The laser light has four unique characteristics that differentiate it from ordinary light source. Coherence, phase with each other, then directionality, the narrow line of beam travel very long distance without energy losses. Monochromatic source, it contains single wavelength or single color. High intensity, very high power output light. Types of laser, based on the active medium, it classified as gas laser, solid state laser, fiber laser, dye laser, free electron laser and semiconductor laser. The laser action. In laser action, to satisfy the condition for population inversion. The population inversion means the number of atom is higher than excited state compared to the ground state atom. How to achieve the population inversion? The external energy source is applied to the ground state atom. In ground state atom is absorbs the energy and goes to ground state to excited state. That means E2 greater than E1. The more number of pumping method is available based on the active medium and active center. In ND-OAG laser using the optical pumping method, in helium neon electrical pumping method, carbon dioxide laser electric discharge method, and semiconductor laser using the direct pumping method. Spontaneous emission is the process in which a quantum mechanical system transitions from an excited energy state to a lower energy state and emits of energy in the form of photon. The stimulated emission is the process by which an incoming photon of a specific frequency can interact with an exited atomic electron, triggering it to drop to a lower energy level. As a result, two photons are emitted. Construction and working of ND-OAG laser. The active medium yttrium aluminum garnet doped with neodymium. Neodymium ions act as active center. It is a four-level solid laser. Optical pumped by krypton flash lamp. The emitted wavelength of laser is 1.06 micrometer. The diagram represents the construction of ND-OAG laser. The construction of ND-OAG laser, the neodymium yttrium aluminum garnet rod and a krypton flash tube are placed in elliptical cavity. The flash tube is controlled with the help of a capacitor. The ends of the ND-OAG rod is placed the optical resonator. One optical resonator is 100% reflecting and another one is 50% reflecting mirror. The working of ND-OAG laser explained with energy level diagram. In ND-OAG laser having the 4-level solid laser, the levels are E1, E2, E3 and E4. Working of ND-OAG laser. When the krypton flash lamp is switched on, the neodymium atoms are raised from ground state E0 to excited state E2 and E3. The neodymium atoms make a transition from E2 and E3 to the metastable state E4 by non-radioactive transition. The spontaneous transition from E4 to E1 emitted the energy in the form of laser in the wavelength of 1.06 micrometer. Emitting laser travel back and forth between the two optical resonator and increasing the intensity, and also induce the stimulated emission. The transition from E1 to E0 is rapid and non-radioactive transition. These are the application of laser. The laser can be applied in the following process: the cleaning, welding, cutting, additive manufacturing, ablation, drilling, engraving, dental, medical, 3D printing, electronics, aeronautics, sensor, jewelry, in automobiles, and also metallurgy. Thank you.